Okay, hi, welcome back to Biology Leap Review. We are still in Unit 3, which is our evolution unit. And in this video, we're going to talk about antibiotic resistance. So leading up to this, we talked about how your different body systems work together to maintain homeostasis. And then we learned about the types of microscopic organisms that can upset our homeostasis in our body. And we talked about bacteria and viruses and how they reproduce. We went into a little more detail about how bacteria reproduce and how rapidly that can happen. And so in this lesson, we're going to see how bacteria have begun, or that's not a good way to say it. Let me start over. In this lesson, we're going to talk about how bacteria are becoming resistant to the medicine that is supposed to kill them. And so if you'll remember from our lesson where we compared bacteria and viruses, we said that bacteria can be eliminated in most cases with antibiotics. And so antibiotics are medicine that you take, doctor gives you, and they're supposed to kill the bacteria population in your body. But somehow, some of the bacteria are becoming stronger than the antibiotics. And so in this lesson, I'm going to show you how that can happen. So we're going to use a computer simulation to look at this, but what we're going to be working with in the computer simulation are these little egg-shaped, or I don't know if you call them egg-shaped, but they're oval-shaped structures in these different colors, and these represent bacteria. And so we have a red bacteria, a brown one, a green one, and a purple one. And you'll notice that each of these bacteria have little openings along their membrane. So the red outline represents the membrane, the cell membrane of the bacteria. And you can see that the red cell membrane has several openings in it, which we're going to call pores, or holes that would allow things to penetrate inside the cell. And so the red one has 6 pores, and the brown one has 5, and the green one has 4, and the purple one has 3. Okay, so with the help of the computer simulation, we are going to investigate how antibiotics kill the 4 different variations of bacteria. So what we have here is a population of bacteria, but it has variation within its population. So some of the bacteria have 3 pores, some have 4, some have 5, and some have 6. Okay, so we've got a population of bacteria maybe living inside of a human, making them sick. And within that population of bacteria, there is some variation in the structure of these cell membranes. Okay, and so let's go to the computer simulation. And I think I'm going to have to stop share and then start a new share. Yeah, here we go. All right. So we are going to start off our computer simulation with equal numbers of the different variations of the bacteria. So we're going to have 10 of the purple 3-pore bacteria, 10 of the green 4-pore bacteria, 10 of the 5 brown bacteria, the 5-pore brown bacteria, and 10 of the 6-pore red bacteria. Okay, and we are going to allow them, we're not going to allow them to reproduce in this first investigation. I just want you to see what happens when the antibiotics are introduced. So we are going to administer 50 milligrams of antibiotics every 3 hours. And we're going to do manual dosing this time, just so I can control it. And so watch what happens when I click the setup reset. Okay, so you see we've got the 4 different variations of the bacteria here. We've got some of the purple ones, some of the green, some of the red, some of the brown. Okay, and when I start the simulation, you're going to see little tiny particles come down from the top of this this pane or this screen here that the bacteria are in. And those are going to be the antibiotics. And the antibiotics are going to start eliminating these bacteria. And our graph over here is going to show us how many of the bacteria are left after the antibiotics are administered. Okay, so let's see what happens. I'm going to start the simulation and I'm going to manually dose antibiotics. So watch as the antibiotics come down from the top of the little window pane. And there they go. And you can see they're eliminating some of the bacteria. And so now all of my antibiotics are gone. So I'm going to pause. And I'm going to look over here at my graph. I'm going to make it a little bit bigger. Let's see. Let me just try this one. And I'm going to probably have to switch share. Let me start the share again. There we go. Okay, so here's our graph. Let me make it a little bigger. Okay, and so you can see that not all of the bacteria were eliminated. Okay, we started off with 10 of all 4 of the different types. And you can see that over time, when we stopped the simulation, it looks like there were more purple and green left here, because you can see the end of the purple line is up here and the green line overlaps the purple line. But then you can see that the brown line is a little lower and the red line is a little lower still. So the bacteria were able to eliminate more of the brown and the red bacteria. So more of the 5-pore and the 6-pore bacteria were eliminated with 1 dose of the antibiotics. So let's think about why that is so. So if you look here, you can see how many of each kind of bacteria that were left at the end of the simulation or after the antibiotics were introduced. And you could see that there were 6 of the 3-pore, which were the purple. There were 6 left. So we killed 4 of them. We started with 10. We went down to 6. And then there were 6 of the 4-pore, but there were only 5 of the 5-pore, which is the brown, and only 4 of the 6-pore, which was the red. Okay, so why would the antibiotics have a harder time killing the 3-pore purple bacteria and the 4-pore green bacteria? Well, if you think about it, there's only 3 openings in these purple bacteria cells, and there's only 4 openings in the green bacteria cells. So there's less opportunity for the antibiotic particles to seep in to the bacteria cell and kill them. Okay, so if you look at the red ones, there's a few red ones left, and there's a couple of brown ones left. You see the red ones have all those openings, all those pores, 6 of them. And the brown ones have 5 pores or 5 openings into the cell. So there was a greater chance that the antibiotic would get into those bacteria cells than the others. So what that tells us is that due to variation in the bacteria population, some of the bacteria are able to survive longer in the presence of antibiotics. Okay, so let's redo this. Let's reset this. Okay, and if you'll remember from our previous lesson where we did all that math with killing the bacteria and then taking the antibiotics, and even though we felt better, we had to keep taking the antibiotics because we felt better because we had killed most of the bacteria, but we hadn't killed all of the bacteria. And so the ones that were left kept reproducing and growing very quickly, and before we know it, we're sick again. Okay, so let's look what happens in that case. So let's set this to reproduce. And we're gonna let the bacteria reproduce every hour this time, because that's as low as we can go, I think. Let me see if I can do, yeah, we can do every half hour. So every 30 minutes, which is pretty close to what we did in the other lesson where we did every 20 minutes. And so we're gonna take our antibiotics every 4 hours, just like we did. And we're gonna auto dose. We're not gonna skip any doses. We're gonna auto dose this time instead of manual dose. And we're just gonna let this simulation go so you can see what happens when a person is sick and they have a bacterial population that has a little bit of variation in it, where some of the bacteria are a little more resistant to the antibiotics and are able to survive better just because of different variation that they have, like having less pores in their cell membrane, like the purple ones and the green ones, as opposed to the red and the brown, which have more pores in their cell membrane. And we're going to see how this population changes over time, even when we're taking antibiotics. Okay. All right. So we're going to set up, reset, and start the simulation. And so here come your antibiotics. And so that was our first dose, but look at those bacteria reproducing. Goodness, they just keep on reproducing every 30 minutes. And we can only take our antibiotics every 4 hours. And so they just continue to grow and grow and grow. And our antibiotics are not doing much good in this simulation. Okay, so now let's pause it and let's look what happened. Okay, so in this simulation, we ended up with 80 of the 3-pore purples, 190 of the 4-pore greens, only 65 of the 5-pore browns, and only 6 or 106 of the 6-pore. Okay, so in this simulation, we didn't have as many purple, but we had the most green, and then we also had a lot of red. Okay, but let's look at what happens now if we increase our dosage. So obviously that was not enough antibiotics. So let's increase our dosage up to let's do it at the maximum, okay? And we're still going to let the bacteria reproduce every half hour, and we are going to take our antibiotics every 4 hours. We're going to auto dose. And so let me reset this, and we're back to just 10 of each of the different varieties of the bacteria. And so now let's see what happens when we increase our dose. Okay, so there goes our antibiotics. And They did a really good job in that first dose. They eliminated a lot. And they're continuing to work, but the bacteria keep reproducing. And now let's pause and look at what's happening now. Okay, so now we got our dosage right. Now we've got, we're taking enough antibiotics to do the trick, but look what is happening to the population of the bacteria. So we are eliminating a lot of the bacteria, but look at the ones we're eliminating. If you look right here at the red, we've eliminated all of the red. So you see here, we started off with 10 of the red that had 6 pores, and we only had a couple of doses. Let's see, we did 3 doses, and we eliminated all of the red 6 pore bacteria. We still have 64 of the 5 pore browns, and we still have 32 of the 4 pore greens. But look at how many of these 3 pore purple bacteria we have. We have not eliminated those well at all. And these are the ones that you would consider antibiotic resistant. And that just tells us that because of that particular variation in those bacteria cells, where they only have 3 pores in their cell membrane, they are very difficult for the antibiotics to eliminate. And so they keep growing. And so if you remember the story from class about the little girl Addie, that she had contracted that staph resistant bacteria, and that staph bacteria that was antibiotic resistant, and she just kept getting sicker and sicker. This shows you how that can happen. And so in that case, we have to keep developing more antibiotics that are stronger and that can kill those bacteria cells. And so if you don't take all of your antibiotics, and let's just say you started off, one more little practice, let's say you started off with only 5 of the 3 pore and only 5 of the 4 pore, and then you had 16 of the 5 pore and 16 of the 6 pore, and you were sick because you had all these bacteria in your body. But look, let's see what happens when we take antibiotics with this. And I'm going to decrease the dosage just a little bit because it happens so quickly. I'm just going to put it at 150. And I'm going to set up reset. And let's watch what happens this time. Okay, so now we've got the antibiotics are coming in and destroying the bacteria. And you can see we're having a little more trouble getting rid of the 5 pore and the 6 pore, but look at what's happening to those purple ones. We've already eliminated the 4 pore. We're up to 3 doses. Okay, let's pause. Okay, so we still are having a hard time getting rid of the 5 pore and the 6 pore, but we even with only 5 of these purple ones to begin with, they just keep on growing. And so you can see how over time, eventually this red line is going down. The brown line is starting to turn down here. Let's dose a little bit more frequently, every 2 hours. see what happens. I want you to see. Well, in that case, we eliminated the purple ones right off the bat. But what I wanted you to see is that it's easier to kill these and harder to kill these. And that's what the bacteria resistance is all about. So anyway, I hope that helps you to understand how bacterial resistance can happen due to variation in a population of bacteria cells. And by taking all of our antibiotics, like we learned in the last lesson, we can eliminate all of those bacteria and not allow the ones that have become resistant to survive and continue to reproduce. Okay, thank you for your attention. And when on our next video, we will look at evolution on a larger scale. We'll begin looking at evolution on larger organisms, and we'll apply this same concept of how variation in a population can allow different organisms to survive better. And we're going to talk about evolution by natural selection, and then we'll talk about the evidence for evolution in our next two videos. Okay, thank you for listening.